Good morning, class. So I am going to go ahead and just start teaching as if I was in the classroom. So this first video, I'm going to do all the review topics, and I want to go ahead and do it so that if you have to review at any point while I'm gone, you certainly can. So what I'm going to do is I'm using what's called OneNote. Most of you guys already know how to do that. And if you hear background noise, I have two dogs in the background. So I'm doing this from home. Um, we will get through all the topics that we need to get through. And as you know, and I announced it on the first day of class, and I already sent out an email to you, that my husband and I are going to go to Ireland. It's a trip that we had planned back in May of 2020. It got canceled, obviously. And now my daughter is getting married in Ireland. So we're going to go watch her get married and then go ahead and do our trip. So I'm going to be gone for 2 weeks. You know that already. I'll be gone from the 7th through the 22nd of September. So we start school and then I'm gone. So I want to make sure that you guys have everything that you possibly need in your Canvas class. In the orientation, I have all different kinds of other instructors that have kind of stepped in and said, hey, if any of your students need help, these are my office hours. So those are all going to be posted or are posted in your Canvas class. So let's get started. I'm going to go ahead and share my screen and we'll get started on the review topics. So here we go. Okay. So this link will also be in your Canvas class. Under each topic, I'll have the link to each page. So that way you can go back to it at any point. Actually, it'll be one link in the first module. So you can just go to OneNote. This is what it will open it up as. Obviously, we're fall 2023. We are Math 1325. 005, and here are all the topics for the first test. So I wanted to make sure and have videos for every topic. I also have videos within the module 1 under each, right before you do your homework. Hopefully you are just following through the module and just clicking from one to the next. You'll do homework 1, and then all the resources are there. Then you'll go to resources for homework 2, and then you'll watch those videos and then do your homework in your MyMathLab. So we'll make sure that everybody is all up and running during that first week of school with MyMathLab, and then we'll go from there. So I'm gonna go ahead and shrink this down so I have more room because I kind of write big. So anyway, these are all the topics that are review topics. So that means you already are supposed to know how to do this. So this should be very quick, mostly painless. If you need to review any of this on your own, please go back to your notes from 1324, your business algebra class, and all of this stuff will be in there, or any other algebra class that you've taken. You will have seen this before. So we're going to start. I'm going to just kind of make one video for each homework. So some of them might be kind of long. So you know what the nice thing about a video is you can fast forward as much as you want. So if there's a topic you don't need to review, just skip forward and get to the stuff that you do need to review. Okay, so the first one is equation of a line. How this applies in the business setting is the very basic one is the cost function. As you sell products, the cost of each product is multiplied by the number of products. So for instance, I always go back to my t-shirt example. If you are selling t-shirts for $15 each and you sell 100 of them, right? That's your revenue. But if you're making these t-shirts, that's the cost. So remember, revenue is what comes into your business. So what you're selling your product for. Cost is what goes out of your business. Okay, so that means that you're spending money in order to do business. So that's the cost of doing business. And then the difference between those two is your profit. It's whatever's left over. Okay, so equation of a line is basically your cost function. So let's just go ahead and kind of review real quick. Equation of a line, you have to have a slope, right? So the slope represents the cost per item, what it costs you to build, the t-shirt, or you build your TV, or whatever it is that you're selling. It's whatever the material costs, what it costs for you to rent the machinery or to buy the machinery, that kind of thing. So that's your slope. And that number can change depending on, if costs go up or costs go down. You also need a y-intercept. And the y-intercept is where, if you look at it graphically, let me get my pen here. If you look at it graphically, the y-intercept is, so if this, and I'm sorry, I can't draw straight lines. If this is our y-axis and this is our x-axis, right? Here's our y-axis. Here is our x-axis. The y-intercept is any point along the y-axis, okay? It intercepts, it crosses over the y-axis, right? And what that represents is your fixed costs. That's where your cost starts. So if it costs me $500 just to get started, just to buy the material, whatever, and then it costs me certain amount every time I do one product, two products, three products, you can see the costs rise, right? So the fixed, or the y-intercept, is where your costs start. That's your beginning point. So that's your fixed cost, is the y-intercept. Okay, so a slope, those are the two things you need. That's it. That's all you need for equation of a line. You need the slope and you need the y-intercept. So slope is found, slope is rise over run. So you can see on my line that I drew over here on the right, the slope is gradually increasing. Okay, so that is a positive slope. If I had a slope down here that went through this y-intercept and went downhill, this is a negative slope. So that means our costs are decreasing. We have a decreasing cost or a negative slope. This is increasing costs or a positive slope. All right, so the rise over the run is how far up and how far over. That's your rise and your run, how far up and how far over. And you can see, maybe you can see, that it's consistent. It's always going to be the same, up and over, up and over. That is your rise over your run. When you're looking at a decreasing slope, it's the same thing. The rise can go down and the run goes to the right. The rise goes down and to the right, down and to the right. So it just depends on if your rise goes up or if your rise goes down. That determines whether you have a positive or a negative slope. And then the formula, so this right here, let me highlight it here. This right here is your slope formula. That's how you find the slope. And the way you do that is you have to have two sets of points. And these are called ordered pairs. The X and the Y is called an ordered pair. Let me get this out of the way here. So the X and Y is called an ordered pair. And each of these points have an address, what I call an address. So for instance, like this one down here could be -3, 0. You always do X first, 0, -3. This one up here could be, 5, 0. I can't talk at the same time. Hang on. It's so much easier to teach when I'm face-to-face, but we're just going to fake our way through it. 0, 500. Okay, these are our ordered pairs. So what we can do is every line has 2 points. So we can start at this one and then maybe have another one over here with another set of points. So this one would be 3, say 600. That would be our other ordered pair. And we can go from there. And those 2 points will give us, using the slope formula, will give us our slope, how it changes, how the X's and the Y's change. And we do that by subtracting the Y's divided by subtracting the X's, and there's your slope. Okay, now there's a couple different formats for equations of the line. There is the slope intercept format, And this is the one that most people know, the y equals mx plus b. That's the one, that's the common one, the one that we see a lot. But then there's also, this is our slope intercept form, y equals mx plus b. Then there's another one called the point slope format. And this one we use to get an equation of a line. And this is the format for point slope. So with this one, you need a point and you need a slope. That's it. This one, you have to find the slope and then you have to find the y-intercept. So what we're going to do is we're going to use this information and we're going to write the equation of a line. So the equation of a line will always come back to this y equals mx plus b. This is our equation of a line. Okay, that's how we're going to write it. So here we go. We are given a slope. So the slope is your m, and then a point is 3, 0. Okay, that's our address. That's where the point is on the y-axis. Okay. All right. So here we go. So we always, whenever you're given a slope and a point, we're going to use the point slope format right there. So it's going to look like this: y minus y1 equals m times x minus x1. So now here is my m. So that's going to go right here. Here is my x1. Here is my y1. So we have y minus 0 equals 3/2 x minus 3. Now, if you notice in the equation of the line, y equals mx plus b, we have a y and we have an x. So that's these points right here. Those are going to be your x and your y. Okay, those will stay there. That's part of the equation of a line. So the only thing you have to replace is, let me get a different color here, is the x1 and y1, which is right here. Okay, so given a slope and a point, you use the point slope format. And then all I'm going to do is just clean it up. So y minus 0 is just y. 3/2 times x is 3/2 x. And 3/2 times -3 is a -9/2. Now, if you aren't sure how I did that, how you multiply fractions, this is a real quick little reminder. I did 3/2 times -3 over 1. And that's how I got the -9/2. I just multiplied straight across. Okay, so if you notice, there is the equation of the line. It's y equals 3/2 x minus 9/2. 3/2 is my slope, -9/2 or -4.5. That is my y-intercept. Okay, so that is when you're given a slope and a point. Now, this one, what do you do when you're given 2 points? Well, anytime you're given 2 points and you have to find the equation of the line, you have to go back to the slope formula. So the y2 minus y1 over x2 minus x1. So here is our x1, y1. Here is our x2, y2. And it doesn't matter what order. I could flip these. But because this is my first and this is my second set, I'll just use them in that format. So here we go. First thing I have to do is find the slope. All right, so finding the slope, I'm going to use, let me highlight this so that it matches. I'm going to use my slope formula. So y2 is -4 minus y1 is 3 all over x2 is 1, x1 is 2. Okay, so I just got those from right here. Okay, so -4 minus 3 is a -7. 1 minus 2 is a -1. So we end up with -7 over +7, which is, I'm sorry, -7 over -7, which is +7. So this is our slope. Okay, so now we are right back to what we just did before. We have the slope and we have a point. Now I can use 1, -4 also. It doesn't matter which point I use. I just pick which one do I want to use. I just picked 2, 2, 3 this time. If you wanted to do 1, -4, you will see it's the exact same equation of a line. So now we are right back to y minus y1 equals m times x minus x1. So again, this is your point slope format. I have a point and I have a slope. So here we go, y minus 3, there's my y value. Slope is 7, x minus the x value of 2, and now I have to clean it up again. Okay, so I'm going to keep the y minus 3 there. I'm going to distribute. Remember, distribute means multiply the 7 through. So 7 times x is 7x. 7 times -2 is a -14. And then I'm going to solve for y. So I'm going to add 3 to both sides. So y equals 7x. 14, -14 plus 3 is a -11. So my equation of a line through those 2 points is 7x minus 11. Now, let me show you real quick. What if I used m equals 7 and then my point is 1, -4? I can do the exact same thing. So y minus a -4, 7 is my slope, x minus x, y minus a negative, that's y plus 4, equals 7x minus 7. And again, I'm just distributing. And then I'm going to subtract 4 from both sides. So I get y equals 7x minus 11, the exact same equation of a line. So it doesn't matter which set of points you use, just pick one. Be bold, pick one and go for it. Okay, now if you aren't sure if you're doing it right, use both of them. Do it the first time, see what you get for equation of a line, do the second time, and you should get the exact same thing. Okay. All right, so now how does this apply when it comes to an application? So now what you're going to do is you're going to be given some information, and all of these are examples from your My Math Lab. So you will see these types of problems again. So we're going to find the equation of a line. Okay, so the minute you hear the term equation of a line, you go, okay, I need a slope, and I need points. Every time you need a slope and points. You can't get an equation of a line without that. So as you're reading, you see it says a plant can manufacture 60 baseball bats at a total daily cost of $5,400. So the minute you see numbers go together, and if you remember from business algebra, your ordered pairs will always be set up in this format, right? It's X and Y. X is always the number of products. Y is always the value of the products. So if I can do 60 bats and it costs $5,400, there is my first set of ordered pairs. Sorry, my dog is chewing on something. Hang on. Okay, and then the next one is 80 bats for a total cost of $6,200. So I have 80 and then 6,200. Hang on 1 second, I got to take that away from it. You'll be enjoying this part. My daughter has a 1-year-old gold yellow lab that I take care of. So she's fun, but she's a lab. Okay, so here we go. So 60 and 5,400, 80 and 6,200. There's my 2 sets of points. Oh, look, if you go back up to this one, do you see how you started with 2 sets of points? Exact same thing. Nothing is different. The only different thing that you had to do is you had to pull that information out of the word problem. So 60 bats cost you 5,400, 80 bats cost you 6,200. There's your 2 sets of points. So knowing you need an equation of a line, again, the first thing you're going to do is you're going to find your slope. So slope is y2 minus y1 all over x2 minus X1. Okay, so 6,200 minus 5,200 is 5,400, sorry, is 800. 80 minus 60 is 20. So 800 divided by 20 is 40. So my slope is 40. Okay, now in the application, what does that mean? What that means is that is your average cost of a bat. That's what it costs you per bat. So for every bat that you manufacture, the materials, the labor, all of it is going to cost you $40 for every bat. So business mind, if it costs you $40 to make it, that means you have to charge more than $40. So if you feel like anything over $40 is too much, you need to pull back on your quality, the quality material. Maybe you'll have to cut back on how many you make so that you can cut down on costs. So it all will come together. These algebra type applications like slope. What does it actually mean in business? It's your average cost. That's what it costs you per bat. Okay, equation of a line. What do we need? We need a slope and we need a point. Well, we found our slope. Here's a point. I can use either this one or this one, doesn't matter. And we're good to go. So now we're going to use our point slope format of the equation of a line. Okay, we have all the information we need. So I'm going to just use the first set of points. So my y is 5,400. My slope is 40. My x is 60. And notice I am not going between the two of them. I use one set of points. I don't mix them up. I only use one set. And now I'm going to, and you're going to hear it a lot, clean it up. So I'm going to clean it up. That means I'm going to simplify it, right? So my y minus 5,400 stays. Now I can distribute this 40 through. So 40 times x is 40x. 40 times negative 60 is a negative 2,400. Now I'm going to add 5,400 to both sides so that I can get my y equals 40x plus 3,000. And that is the equation of a line. That is my cost function. So what do all these mean? So again, this is my slope. My slope is the average cost per bat. So what is this value? So this 3,000, this is what's considered your fixed cost. So fixed cost is what does it cost you to run your business? You're not it has nothing to do with the manufacturing, the actual cost of per bat. That's the $40. This $3,000 is fixed cost. It's an amount of money that you have to put out whether you manufacture one bat or not. So it could be the cost of getting your building, or the cost of hiring new employees, or the cost of paying your utilities. So all of those things are kind of separate from the actual production of whatever the unit is that you're manufacturing. So in this case, the actual production of the bats. Okay. All right. So let's go through the questions. So A says, assuming that daily cost and production are linearly related. So remember, this is a linear equation, right? Your x is to the first power and your y is to the first power. That's linear. Find the total daily cost of producing X baseball bats. So here we go. Our function is the cost. So this is the same as y, is 40x plus 3,000. That is your cost function in terms of x. Okay. Then we're going to graph the cost between 0 and 200. Okay, 0 and 200. Now, I'm going to introduce to you something called Desmos. Sorry, most of you have already seen it. If you took my 1324 or Mrs. Bradshaw's or Mr. Anderson's, you already have used Desmos before. So I'm going to switch over to Desmos. Get to it. Get this out of the way. There it is. Okay, so Desmos is a great graphing tool. So if you don't have a graphing calculator, all right, you do not need to buy a graphing calculator, right? They're very expensive, and this is, you know, for most of you, this is your last math class that you're gonna use. So we're going to graph 40x plus 3,000. Okay, now you can see, right? There's the line. So as soon as I start adding values now, or the 3,000, now all of a sudden it's too big for my graph. So I'm going to use it. So I have 0 to, let's say, 5,000. Oh no, we only wanted it to 200, right? It was 0 to 200. And then for the y-axis, 0. And you can play with this. So because I'm going to start at 3,000, remember the 3,000 is your y-intercept, so that's where I'm starting. So I'm going to go up to, say, 8,000. Okay, now you can see that my graph works, right? Now you can actually see the graph. So I am graphing between 0 and 200. Let me make it a little bit smaller so you can see it. So here is my value between 0 and 200, okay? And you can see that there's points. Now, look at right here, 1,000, 2,000, 3,000. There is your, right here is your y-intercept. That's where your line crosses the y-axis. Okay, so this, all I want you to use Desmos for is to get an idea of what your graph looks like. Okay, now when you actually graph it on MyMathLab, you're going to have to, you know, put the points in. So here's how I do this. So this is for B. Okay, this is, I'm going to show you how to graph it manually, if you will. So I know I'm only going between 0 and 200. So I'm going to take my equation and I'm going to find the cost when x is 0. That's what this says. Remember functional notation. So when x is 0, I'm going to take out the x and plug in 0. And you can see I get 3,000. So this is my first point. Okay, now if I go back to Desmos, there it is, 0, x is 0, y is 3,000. Okay, so now how do I get the other point? Well, I know my other end is 200. So when x is 200, take out the x, plug in 200, and I get 40 times 200 is 8,000 plus 3,000. That is my 11,000. Oops. Okay. So when I have 200 bats, it costs me 11,000. Well, look, if I go to my Desmos, here is 200. Look at there. There's 11,000 right there. Okay, here's 10,000 plus one more is 11,000. So every line needs 2 points. So if I'm going to graph it, I know it's always going to be positive, right? So at 0, my y-intercept is 3,000. At 200, my y-intercept is 11,000. So you can see this is just a very rough sketch. That's it. All right. And then last one is interpret the slope and the y-intercept. I kind of already talked about that. The slope, excuse me, is your average cost per bat. And the 3,000 is your y-intercept. That is your fixed cost. That's what it costs you just to open your doors for the day. Okay. All right. So that is an application of when you are getting equation of a line. All right. Let's skip down here. Okay, so the next review topic is just kind of terminology. So domain is what are the values that X can be? That's what the domain is. So range is what are the values that the Y's can be? Well, we have to concentrate on the X values, the domain of the function, because that's what restricts us. So there's some restrictions. So with a polynomial, I'll write it over here, with a polynomial, that is anything that looks like this. And so on, okay, all down to a constant, all right? Well, all this means is, let's say 2x to the fourth plus 3x to the third plus, x to the second minus 2x to the first plus a constant, okay? That's a polynomial. Well, with a polynomial, there are no restrictions. My X value can be anything. So the domain on a polynomial is from negative infinity to positive infinity, or I can say all reals, all real numbers. All right, so with the polynomial, there's no restrictions. But when I end up with a fraction, right, there are restrictions. So for instance, with a fraction, does anyone remember what the one value you cannot have in the bottom? And so sometimes I'll ask you on these videos, and I want you to not just blindly watch these. I want you to actually be active in it. So with a fraction, you cannot have 0 in the denominator. Running out of room. Okay, so you cannot have 0 in the denominator. All right, so how do you solve these? You set the denominator to not equal 0, and then you solve. All right, so I'm going to do these as we go. So a fraction restriction, you set the denominator to not equal 0. Oops, that's a 0, not a 6. Right, and then you solve. So I'm going to add 3 to both sides. So X cannot be 3. Okay, that is my domain restriction. So how would you write this? Well, on MyMathLab, whenever they give you a place to put in your answer, next to it or below it in blue, it'll give you how MyMathLab wants the answer. So if it's in interval notation would look like this. It's all the values from negative infinity to 3, and it's a parenthesis because it does not include 3. And 3 to infinity. And again, the parenthesis says it doesn't include that. All right, so here we go. Here's another one. We're going to set the denominator. So denominator only. You don't have to worry about the numerator. I can have 0 in the numerator all day. It's only the denominator that I have to worry about. And then I solve. This is a 2-step equation. So I'm going to subtract 3, and I end up with 7x does not equal -3. Then I'm going to divide by 7. So X cannot be -3/7. Okay, so another way to see this, if you aren't sure how to write it, if you have a number line, okay, and you have -3/7 is the only value that the domain cannot be, well, you have all the values in front and all the values behind. Okay, so same thing on this one. If I had 3 was my domain restriction, all the values in front and all the values behind. So with this one, if I were to write it in interval notation, it would be all the values behind. So that's all of this. I'm going to highlight this. So all of this is this side. And then all of this is from -3/7 to infinity. Okay, so that's when you have a fraction. That's the only restriction with a fraction, is you just cannot have 0 in the denominator because it makes it undefined. All right, the next one is a radical. So remember, a radical is anything that has a root. So it could be a square root, it could be a fourth root, it could be a sixth root, it could be an eighth root. So notice all of these numbers, and this is an assumed 2, all of these numbers are even. All right, so that's a radical. That's what the even indexed radical means. If this was a cube root, I can have negative. If it was a fifth root, I can still have negative underneath. So it's only restricted to negative values under an even indexed radical. So because you can't have negatives, you're going to set the radicand, that's the answer under, or the value underneath the radical, to greater than and equal to 0. All this means is it has to be positive. That just means positive values. So we can't have negative values underneath an even indexed radical, right? So let's try these. So B says the square root of 3x minus 1. So I'll do it over here. 3x minus 1 greater than or equal to 0. And again, you're just solving. And so all of this solving, you guys should be super comfortable with. There should be no question on how to solve these. So this is x is greater than or equal to 1/3. So again, if I were to graph it, it would look like this. Greater than and equal to means solid dot. Okay, with interval notation, it would be a bracket, which means it's included 1/3 to infinity. And infinity or negative infinity always has the parenthesis. Okay, this one is a even indexed, so I'm going to set it to x minus 3 greater than or equal to 0. Just add 3 to both sides, so I have x is greater than or equal to positive 3. So again, on a number line, it's going to be a solid dot and everything larger. Okay, now if you look at this, if I put in a number, let's say I put a number, 1, because 1 is over here, right? 1 minus 3 gives me a negative 2 underneath. So that's why it has to be all values greater than or equal to 3. Now I can have 0 under there. If I plug 3 in, 3 minus 3 is 0, that's fine. I can have 0 under a radical. I just can't have a negative under an even indexed radical. So with this one, it would be bracket 3 to infinity. So this is called interval notation. Now this one is an odd indexed. This one right here is an odd index. So this one has no restrictions. So it's any value, all reals, negative infinity to positive infinity. Okay, and then the last one, let me get this out of the way one more time. I like it up here better. The last one is log functions. So log functions is the same as a radical. You cannot find the log of a negative value. So again, you set the log to greater than or equal to 0, which means you can only have positive values with a log. So it's the exact same thing. Here's my log. I'm going to go 2x minus 5 greater than or equal to 0. Solve for x. So it's x is greater than or equal to 5/2. Now, one real quick thing, and it's not showing it on here, but if I had, log base 5 of negative 3x plus 1. Now, because there's a negative in the log, that doesn't mean that this whole thing is negative, because x could be negative 5, which would make this whole thing positive. But what I wanted to show you is if you set this up where it's negative 3x plus 1 is greater than or equal to 0, and you solve, and I divide by a negative, this is where it gets tricky. When you divide by a negative, you have to flip the inequality sign. And it's something that doesn't happen very often, but it does happen. So just remember, when you divide by a negative with an inequality, you have to flip the sign. Okay, so here we go. X plus 4 has to be greater than or equal to 0. So I'm going to subtract 4 from both sides. So I get x is greater than or equal to -4. So again, on a number line, greater than or equal to goes this way. So it's bracket -4 to infinity, parenthesis. This one, bracket 5/2 to infinity. This one. So notice the inequality is going in the opposite direction. So that means it's going to be to -infinity 1/3 bracket. So it does include the 1/3, but it's all the values less than. So if we did this on a number line, it would look like this. Okay, so that can happen where when you divide by a negative, you have to flip that sign. Okay, all right, so this is one that got students a lot in 1324. So this difference quotient. So the good news about the difference quotient is you will only see it during this first module. After the first module and after the first test, you don't see it again until the final exam. So it's not going to completely go away, but at least you only have to suffer through for a little bit. So what is the difference quotient? So remember, the difference quotient is a way to find slope. It's just another example of slope. Okay, so let's say we had, let's say we have this graph like that. And let's say we have these 2 points. I'm going to do a point here and a point down here. Okay, and I want to know, I want to know what is the slope between those 2 points. Okay, that's difference quotient. So if we call this first point x, so this is x, and then this point right here, let's say we add a value called h. It's a distance, right? H is just a distance. We don't know how big it is. We don't know how long it is or how far it is. All we know is that we're calling it h. It's an unknown distance. Well, this point right here is going to be called x plus h. So it's the x plus whatever this distance is called h. Okay, so for our y value, this one right here is going to be f of x. This one right here is going to be f of x plus h. Okay, all we're doing is we are finding using the slope formula. So remember from before, the slope formula is y2 minus y1 over x2 minus x1. Well, if I use this scenario where we don't know what h is, right? We know it's a distance, we just don't know how much it is. And I use this exact same scenario, I can find 2 points. My first point is called x and f of x. Okay, here's my first point. My second point is x plus h and f of x plus h. Those are my 2 points. Well, I can use slope formula to figure that out. And that's where the difference quotient comes from, because my slope formula is y2, which is f of x plus h, minus y1, which is f of x, all divided by my x2 minus my x1. Okay, now I put this x plus h in parentheses just because it's easier to see it, right? Whenever there's a plus sign, that means that's one unit. You don't want to split those up, right? So how do we get the difference quotient? Well, the top is just f of x plus h minus f of x. And look at the bottom, x plus h minus x. Well, these x's cancel, and that's why there's only an h on the bottom. Okay, so difference quotient is just slope. It's just a very abstract way to find slope. That's all it is. Okay, so you just want to get that kind of mental picture in your head that it's just slope. So if I am finding slope using this 3-step process, then it's actually quite easy. This says take out the x and plug in x plus h. So I'm going to do exactly that. Here's my x. So I'm going to take out the x and plug in x plus h. And now I'm going to simplify it. So that means I'm going to distribute. So 3x plus 3 times h plus 1. That is when I take out the x and plug in x plus h. B says, now take your answer that you just got and subtract off the original function. So this is the answer I just got, and I'm going to subtract off the original function. Notice I put everything in parentheses because I'm not, if I take the parenthesis off, let's say I take it off here and here. So I am not just subtracting 3x. I'm subtracting that whole thing. Super important concept. All right, so you got to make sure that you push that negative through the whole thing. So the first part stays the same. Now I'm going to push this negative through, so minus 3x minus 1. And now look, I have a positive 3x and a negative 3x. I have a positive 1 and a negative 1. So the only thing that's left is 3h. That is the answer to B. Okay, so the last step says, okay, now take the answer that you got in B and divide it by h. So this is the answer I got in B, and I'm dividing by h. Well, look, when you're dividing and everything is showing multiplication, there's no more plus signs, I can just cancel that. So I end up with 3. Now, what did we originally say the difference quotient was? The difference quotient is the slope. Well, when you look at this equation, this is an equation of a line. The value next to the x is your slope. So literally the slope is sitting right there. But you can see, walking through the steps of difference quotient, I can find slope. Okay, now with a linear equation, super easy, right? The slope is sitting right there next to the x value. So what do we do? Here we go. What do we do when you have something that's not linear? So now when you look at this function, 2x squared minus 3x plus 5. So let's go back to Desmos, 2x squared, okay, 2x squared. And all I'm doing is I am just typing in, is that the right one? Typing in, yes, the function, okay? Well, here is our slope, or here's our quadratic, right? So we have x squared, so now it's a quadratic, okay? So you notice the first one, 40x plus 3,000, right here, linear, right? It's a line. 2x squared, now all of a sudden it's a parabola, okay? So this is called a parabola. Well, if I were to ask you what's the slope, what's the slope right here, right at that point, you can see if I were to brush a line right across that point, that is called a negative slope. But what if I wanted to know, okay, well, what's the slope over here? Well, this one, the line is positive. So now my slopes change. Or like right here, if I wanted to know what's the slope right here, well, this is a 0 slope because it's a horizontal line. So with a parabola, it depends on where you're looking, right? It depends on what part of my graph am I looking to find the slope. So what's cool about that with this difference quotient, gotta get out of here, is when I have a parabola, I can find the slope anywhere on that graph. Anywhere, doesn't matter, I can find it. So we're going to walk through the process of the difference quotient. So A says, take out your x and plug in x plus 2 or x plus h. So 2 times, I'm taking out my x and I'm plugging in x plus h. I'm taking out my x and I'm plugging in x plus h. Okay, now I've seen some people do this. Every time they see an x value, they plug in a set of parentheses and then they just pop in that x plus h. Okay, so here is where a lot of students mess up, right here. So over on the side, I'm going to do this x plus h squared. Okay, x plus h squared means x plus h times x plus h. That's what that means. It doesn't mean square the first one and square the second one. It means take that whole thing and multiply it by itself. So you have to do FOIL. Do you remember FOIL? You're distributing. Another way that you can do this, if you don't like FOIL, is you take the x and multiply it by x plus h. And then you take the h and multiply it by x plus h. So you can see when I do it this way, I lined up the like terms. So I end up with x squared plus 2xh plus h squared. Okay, or FOIL, x times x is your first, you get x squared. The outside is xh, the inside is xh, and the last is h squared. So that's where that 2xh comes from, because there's two of them. Okay, so this is a big mistake that people make. So x plus h squared is x squared plus 2xh plus h squared. Every single time you're going to use this. It's the exact same thing. Okay, so that will never change. So, excuse me, I'm going to take out the x plus h squared, and I'm going to replace that with x squared plus 2xh plus h squared. And now I'm going to distribute. 3 times x is 3x, negative 3 times h is negative 3h, and then plus 5. Okay, so again, this x plus h only gets attached to the value in front of it, not anything after it. Okay, so I'm going to again distribute. So 2 times x squared is 2x squared. 2 times 2xh is 4xh. And 2 times h squared is 2h squared. And then I'm just going to repeat. So this is the answer to A. I took out x and I plugged in x plus h. Now B says, do it over here. B says, take that answer that you just got and subtract off the whole thing. So this is the answer I just got. I'm just repeating it. And now I'm going to subtract off. And remember, I'm subtracting off the whole thing, not just the 2x squared, which means this negative has to be pushed through the whole trinomial. So it becomes negative 2x squared, positive 3x, and a negative 5. And then I'm just going to repeat this, rewrite it. Okay, so now I can start canceling. The 2x squareds go away. Negative 3x, positive 3x, positive 5, negative 5. So all I have left, and this will happen every single time you do difference quotient. Your answer to B, every term will have an h in it. That happens every single time. That will never change. Okay, and then C says, okay, take the answer that you just got, this 4xh plus 2h squared minus 3h, and divide that whole thing by h. Well, this is where a lot of students get lazy on me. So don't do this. You have to factor out an h. You can't just go through and cancel, because if I go through and cancel, I'm going to accidentally cancel both of those h's. Okay, so don't get lazy. Just go through and factor out, take one h out of all three of those terms. Okay, so now you can see, oh, now I have multiplication. Now I can cancel. So the difference quotient is 4x plus 2h minus 3. That's your difference quotient, or the slope. Okay, now here's the beauty of this. So let's go back to our Desmos. Okay, here's our Desmos. So our slope, difference quotient, oh darn, I forgot it already. Hang on. 4x plus 2h, okay. Minus 3. Okay, 4x plus 2h minus 3. So there's our difference quotient. Okay, that's our slope anywhere on this. Well, if h is a value that's really, 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 really tiny, so like just about 0, like 0.000000001. It's not 0, but it's super, super close to 0. I can pinpoint anywhere on this graph what the slope is. Because if h goes to 0, my slope at any particular point is 4x minus 3. So for instance, if x is 0, yeah, because it's going to be really small. So if you notice, let's see if I can make this bigger. So when you look at this original function, it's because the values are so, we're going from 0 to 1,000. You can't see it very well. But if I were to get this really, really big, I don't know if it's going to show it or not. You can see that, you see how the value or the parabola crosses right here? Well, it's crossing at 5. So my 0 slope is going to happen somewhere in here. Okay, it's not going to be exactly like right at 0. So that's why if I said x was 0, so if x is 0, okay, if x is 0, so let me get my pencil here. At 0, my slope is going to be -3. Well, because I made this so big, and it's a big, you can see it's a negative slope. So remember, it's not crossing at -3. It's a slope of -3. So that means it's angling down. It's a decreasing slope. Okay. If I said x was 6 over here, what if I wanted to know, okay, what's the slope right there? Well, just from the picture, it should be a positive slope. So 4 times 6 minus 3, 24 minus 3 is 21. That's a positive slope. Okay, so the power of the difference quotient when h goes to 0 is very powerful. And the next lesson, we'll see just how powerful that really is. Okay, so let me clear this, get out of here, get back to here. Okay, so that's your difference quotient. Be comfortable with it. It's a lot of algebra, that's all it is. You are substituting x plus h for x. You're simplifying it, distributing, adding like terms, you're subtracting polynomials, and then you're dividing an h off at the end. Okay, it's all algebra. That's all it is. There's no mystery to it. It's just making sure that you have the signs right, make sure that when you subtract off the whole thing, and so on. Okay, all right. Oh boy, how long has this been? Okay, so the next one is, now we're going to apply it. Okay, we're going to apply what you just learned. So some things about, we already kind of talked about this, what the revenue function is. The revenue is the price of the item times the number of items. That's what money comes in. So revenue is R of X right here. R of X equals P, which is the price, times X, which is the number of items. Okay. Your maximum revenue is your vertex. Okay, so when you look at our parabola, I'm going to go back out again. When you look at our parabola, the vertex is at the very bottom. Okay, that's the vertex. If I had, let me change the values on here. Let's try another one. If I had a negative 3x squared, okay? Now, so we're looking at the green parabola now. Now, the vertex is the highest point, okay? Well, it makes a big difference. The first term is a negative. So think of this as a sad face. It's a frown. It's negative, okay? So that's a maximum. Where this one, The blue parabola, that first term, 2x squared, is positive. So it's a smiley face. That's one way you can remember it. So it's happy. It's a positive. Well, when you have a positive first term, that vertex is your minimum. So it's the lowest point. So a negative first term, you have a maximum. Positive first term, you have a minimum. Okay, important things to identify. All right, so the parabola in the application is your profit and your revenue. So remember, linear equation is cost. Parabolas, which are your quadratic equations, that's your x squared. Quadratic equations is revenue and profit. Okay, so the way you find the vertex, so vertex is either the high or the low. So let me draw this for you. So we have it here. Here is our maximum. So this is when you have a negative first term. When you have a parabola that looks like this, the vertex is a minimum. And this is when you have a positive first term. Okay, so max or min, that's vertex. So this is where you need to put this together. If you have maximum or a minimum, that equals vertex every single time. Okay, so when we transition from just, how do you find the vertex to you're reading a word problem and you have to find the maximum, you have to put those two words together. Okay, that's part of being able to do word problems. All right, so how do you find vertex? Well, you use the vertex formula. So remember the vertex formula, and again, this was from 1324. The vertex formula to find the x value is negative b over 2a. To find the y value is you plug that value back in, okay? So remember, the maximum or the minimum, that's your vertex. Your vertex is always a point, so you have to have an x and a y value. To find the x value, you use your quadratic equation, negative b over 2a. To find the y value, you find that negative b over 2a value and you plug it back in. Okay, so let's try it. Marketing Research Department established the following price, demand, and revenue functions. So price demand just means price. That's the price that the consumer is demanding that you use. P of X is wholesale price in dollars. X is million items. So if it says 1X, that's 1 million. 2X, 2 million, okay, can be sold. Or if X is 2. And R of X is in millions of dollars. And the domain is 0 to 15. That means, say, we're only looking between 0 and 15 million items, okay? All right, so your revenue function, remember, is the price times the number of items. So again, here's your price. Here's the number of items. So all we did is we just distributed. X times 75 is 75x. X times 4x is 4x squared. So we're going to graph the revenue function. So again, you go back to Desmos. And again, Desmos is just a tool. You should know how to graph a function, all right? If you know how to graph a function, Desmos will match, right? So that's the idea, is you want to be able to use the tool to verify that you know how to do this. All right, so I'm going to actually I'm going to show you how to graph it first, and then or mathematically, and then I'll show you on Desmos. Okay, so we know our domain is between 0 and 15. Okay, so if I'm going to graph the domain function or the revenue function, if my revenue is 0, that means I'm going to take out my X and plug in 0. Well, that makes this real easy. So my first point is at 0, 0. When I have 0 products, I have 0 revenue. Makes sense, right? Well, what if I have, say, 15 products or 15 million products? Plug in my 15. Whenever there's a X, I'm plugging in 15. Now I'm going to use my calculator. Well, no. So 75 times 15 is 1125. And then 4 times 15 squared is 900. So 1125 minus 900 is 225. But remember, this is in millions of dollars. So $225 million. That's my revenue when I have 15 products. Okay, now a parabola is not like a line, right? A parabola has more to it. So you might need to pick more points between 0 and 15 to be able to graph it. But just to save time, let's go back to our parabolas. Just take this one out. Actually, I don't need to see that. So it was a negative 4x squared plus 75x. Okay, so there's our parabola. Okay, there it is. So we have 2 points, right? 0, 0, and 15. Where was 15? 15 is about right here. And that's one thing that's nice about Desmos is you just put your cursor and click on it, and it'll show you the points. See, there it is, 15 to 25. So I know I'm in the right area. All right. So, but with a parabola, 2 points isn't going to be enough. So we always need to find the vertex. Okay, so we picked 2 points. Now we're going to find our vertex, because the vertex gives us the high and the low, either the high or the low. This one, since our x squared term is negative, we're going to have a maximum. Okay, so to find the vertex, it's negative b over 2a. And remember, our revenue function, if you put it in descending order, which that is how you get your A and B. So you have to rearrange it. Our A is negative 4 and our B is 75. So we have negative 75 over 2 times negative 4. So we have a 9.375, okay? So remember, this is in millions, right? X million items. So 9.375 million. So 9,375,000 products. That's where our vertex is. To find our Y value, we're going to take out our X and plug in our X value. So you are going to need a calculator. These, I've used these TX30s, super easy to use, 15 bucks. You can find them at HEB, Walmart, Target, wherever. CVS Pharmacy even has them. So that way, and it's solar powered, so you don't have to worry about batteries. The other thing is you can borrow calculators. You can borrow a graphing calculator for the whole semester from the math lab. So I'll give you more information on that if you want. So here we go. Order of operations, 9.375, oops, 9.375 squared times negative 4 is negative 351.5625. And then 75 times 9.375. I write things down all the time because I don't want to have to redo it. So 351.5625. Okay, that is our Y value. So again, what does the Y value represent? This represents our revenue. So remember, your vertex is X and Y. It is X is the number of products, Y is your dollar amount. So same thing. This is X value is the number of products. The Y value is our dollar amount, so our revenue. So again, in millions. So 351,562,500. So all I'm doing is I'm multiplying, I'm moving that decimal over 6 times because million has 6 zeros. Okay? Yeah, 6 zeros. All right. So we have all the information we need. We're graphing the function. Okay, so we know that our maximum is at 9.375. We can go back to our Desmos. Here's 10, so here's 9.375. You put the cursor there, and there's 351.563. So we know we did it right. Okay. All right. So once you, I think in my math lab, they give you, it's a multiple choice, so you'll be able to see which graph it is once you get a few points. So that you can identify which graph is correct. All right, so here we go. B says, find the output that will produce the maximum revenue. So look, maximum means vertex. Output means the number of items. That's what output is. So our output equals our X, which equals 9.375. So 9,375,000. Okay. C asks, what is the maximum revenue? So maximum revenue equals our Y value, which is 351.5625 millions. Okay. And then D is asking, okay, what is the price, the wholesale price per item to get the maximum revenue? Well, we're going to go back to this price function, right? So we are going to find the price at 375. So it's 75 minus 4 times 9.375. So our price is 37.5. So 37.50 each. So that's what the price demand is $37.50. Okay. All right. Let's see how many more we just got one more. Okay, perfect. All right. So now we're talking about, so that was revenue, that was price. Revenue is price times the number of products. Remember, we talked about cost. Cost is what the business has to push out. That's what business spends, the cost of running a business. Revenue is all the money that comes in. And the difference between the two is your profit. That's what goes in your pocket. Okay, so your profit function, so profit, capital P, is revenue minus cost every time. Revenue minus cost. And that should logically make sense. All the money that comes in minus the money that you spend to run business. That's your profit. Okay, so here we go. Company manufactures microchips, use the revenue function. So there's our revenue function. So we're going to write it. Revenue function equals 72x minus 5x squared. I'm going to rearrange it. Negative 5x squared plus 72x. There is our revenue function. To answer blah, blah, blah. Here's our cost function. 124 plus 12x. Answer parts A through D, where X is in millions of chips. Revenue and cost are in millions of dollars. Both have a domain between 1 and 20. Okay, so there's our domain. That's our limitation. That's our restrictions. We only want to figure out between 1 million and 20 million number of chips. Okay, form a profit function. So here's our A. A says profit is revenue minus cost. Well, I know what my revenue function is. And I can subtract off my cost function. Notice I'm subtracting off the entire thing. So my profit function in terms of X is negative 5x squared. 72x minus 12x is 60x minus 125. So here's what I did. I pushed this negative through, and then I added like terms. Okay, so I got negative 125 minus 12x. So 72x minus 12x is 60x, and then negative 125. So here is our profit function. Then the question is, what's the relationship between the intersection points of the revenue and the cost? So let's look at that in terms of Desmos. So our revenue, let me change this, is negative 5x squared plus 72x. Our cost, I forget what our cost was, 124 plus 12x. Oops. There's our cost. Okay, so I'm going to make this bigger. Okay, So here's what the question is. The question is asking, interpret where these two things intersect. That's what the question is. What does that mean? What does that mean when two things intersect? Well, what that means is that's where things are equal. That's where the revenue and the cost are equal. Okay, so if I were to do negative 5x squared plus 72x equals 124 plus 12x, and I had you bring everything to one side, right? Bring everything over. Well, if I asked you to bring everything over, I would subtract 12x and I would subtract the 124. So I'd end up with negative 5x squared plus 60x minus 124. Because I moved everything over, that becomes 0. Well, that is your profit function. So where these two intersect, that is telling you that is what's called your break-even point. Right? That's where you are not going to make a profit, but you're not going to lose money either. Those are break-even points. Why is there two of them? Well, because everything in between the break-even, everything here, that's all profit. Right? So you aren't going to make profit just because you continue to make products, right? More isn't necessarily better. There's a sweet spot where you're going to make profit. Will you make the most profit? Not always. Like over here, you won't make the most profit. The most profit is going to be made up here somewhere. Okay, so profit is above cost. Anything above cost is going to be your profit. Anything below cost down here, that's loss. So anything down here, that's all going to be loss. So where the two lines, where the revenue and the cost intersect, that's your break-even points. Okay. All right. Let's finish this. Okay, so that's your relationship, break-even points. I'll write that in here, break-even. All right, find the x-intercepts to the nearest 1,000 chips. Find the break-even point to the nearest 1,000 chips. Okay, so what we're doing is we are looking for the x value. Okay, we're looking for the x value. Well, that's different than vertex, right? If we were looking for the vertex, the maximum profit, we would just use your vertex formula. But we're not looking for that. We're looking for break-even points. Okay, so break-even points are found by either factoring or the quadratic formula. Okay, so again, that's review. So the quadratic formula is, you're looking for x, right? That's your break-even points. X equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Okay, so here is our A, B, C. Break-even points of the profit. So here we go. X equals negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. Okay, so again, order of operations, I'm going to do everything underneath the radical first. So 60 squared, put this over here, is 3,600. And then I count the negatives, 1, 2, 3. That means I'm going to subtract. So now I can go 4 times 5 times 125 is 2,500. 2 times negative 5 is negative 10. So 3,600 minus 2,500 is 1,100. So I have negative 60 plus or minus the square root of 1100 all over negative 10. So I'm going to bring this down here. So square root of 1100 is 33.17. I'm just rounding. So I go negative 60 plus 33.17 divided by negative 10, and I get I get 2.683, and then negative 60 minus 33.17 divided by negative 10, and I get 9.317. Okay, so those are the two break-even points. Now, if you want to double check, let's look. Put your cursor, 2.64 works. Put your cursor, 9.347. So again, that's why I like to use Desmos, because you're doing the math, but the math needs to match, right? It needs to match. So it needs to be verified. So that's why I do both Desmos and do the actual calculation. So you have to know how to do both. Okay, so there's your break-even points. And then the value, let's see, find the break-even points. Okay, so we were able to do that. So to be able to find the Y value, no, we only wanted to know the number of chips. So this is your X value. So we're good there. So this is our answer to C, is here. And then D says, find the value of X that produces the maximum profit, and then find the maximum profit. So again, maximum equals vertex. Okay, so quadratic formula, this is going to be important. Break-even points, you're factoring or using the quadratic formula. Maximum or minimum, you're using vertex. That really needs to be in your notes. You have to know that, because that will really help in knowing what formulas to use. Okay, so we're going to use the vertex formula. So X equals negative B over 2A. So negative 60 over 2 times negative 5. So negative 60 over negative 10. So our number of chips is 6, and it's to the nearest 1,000. And X represents millions, so 6 million. So this is 6 million chips. All right, that's our X value. The Y value is when you plug the X value back in to the original function. So plus 60 times 6 minus 125. So negative 5 times 36, which is 6 squared. It's negative 180. 60 times 6 is 360 minus 125. So negative 180 plus 360 minus 125 is 55. So $55 million. Okay, so the X value is the number of chips, 6 million chips. The Y value is the actual profit. Okay, that's your profit. And then compare it to the maximum revenue. So if we go back to our revenue function, we're going to find the vertex of the revenue. Okay, so the revenue, let's see, we'll go down here. So the max revenue. So this is max profit. So again, maximum means vertex. So your revenue, I got to rewrite it because I can't remember it, was negative 5x squared plus 72. Okay, so to find max revenue, we need to find the number of products. So we have 7.2 million products. And then to find the revenue, the actual revenue, we plug in 7.2 back into the original function. So 7.2 squared times -5 and then 72 times 7.2 is 518 minus 259.2. So our max revenue is $259.2 million. So the difference between the two, so the difference is 204.2 million. That's the comparison of the two between the revenue and the profit. Okay, we're going to stop right there. That's our review, and then I'll jump into the next one.